Hi, I'm Rick Kephart, Director of Research and Technology, and I want to talk to you about Ovation Embedded Simulation. Embedded Simulation is an exciting new Ovation product with endless applications and value. Over the next couple of minutes, I would like to show you some of these key features of this exciting new product. If you're not familiar with simulation technologies in general, let me take just a moment to describe some of the benefits and values that simulation technologies enable. Operator training has traditionally been the #1 use of simulation technologies. While this is still true, the value proposition of simulation extends far beyond operator training. Engineering is another area where significant value can be derived from a plant simulator. Some specific examples where customers have realized quantifiable benefits and values from simulation include faster startups and unit load changes, mitigation of abnormal situations and unplanned outages through operator training scenarios, offline testing and dynamic verification of control logic modifications. Many customers have utilized a simulation of the plant to develop the final design prior to construction, and in many cases, completing the factory acceptance test on the plant simulator. At Emerson, we are utilizing simulation technologies in everything that we do. The Ovation Embedded Simulation product represents a unique step change in DCS architecture by incorporating simulation functions directly in Ovation. Essentially, the Ovation Embedded Simulator is a set of model algorithms along with an execution environment that are integrated directly in the Ovation architecture. In the same manner that control algorithms implement control functions such as PIDs, summers, transfers, etc., the model algorithms implement first principle simulations of individual plant components and equipment, such as pumps, valves, heat exchangers, and turbines. The models are based on first principles and solve the basic physics equations of fluid mechanics, thermodynamics, electricity, and rotational dynamics. The algorithms execute directly in a virtual controller, in an identical manner as the standard control algorithms. In fact, simulation model algorithms can be incorporated on the same control sheets as standard control algorithms. For example, there is fundamentally no difference between a pump model algorithm and an AND gate algorithm other than their function. One of the key aspects of Ovation Embedded Simulation is that we can support a mixed fidelity simulation when the simulator is comprised of both high fidelity first principles models and tieback simulation that incorporates standard control algorithms to create a mixed fidelity simulator. This approach enables the end user to decide which plant systems are modeled in high fidelity and which systems are acceptable to be modeled in tieback simulation. The key feature of Ovation Embedded Simulation is that the identical software that runs in the actual control system is also the same software that makes up the simulator. This ensures that the behavior of the simulator matches the behavior of the actual plant to a very high degree of accuracy. Incorporating simulation directly into the Ovation architecture provides multiple benefits. These include the tool set. The same engineering and configuration tools, such as Developer Studio and Control Builder, that are used to engineer the plant are also utilized to engineer the simulator. It is the identical engineering tools with no changes. Since the simulator is integral to Ovation, we have complete control over the environment and functions. No third-party components are necessary. Emerson can tailor the simulator solutions to a particular plant, including specific model features to capture behavior that may be unique to a specific plant. Additionally, upgrades can be performed directly on the simulator as a dry run prior to be applied to the actual plant. This allows engineering personnel to evaluate the impact of new software, as well as allowing operations personnel to become familiar with new features and enhancements that may be part of a new Ovation software release. As I mentioned previously, the Ovation Embedded Simulator utilizes the standard Ovation toolset. Everything is built around Developer Studio, and it allows us to create new control sheets or open existing control sheets. In this case, I have an existing control sheet that's part of a simulation that implements a aux boiler simulation, and on the sheet we can see multiple Ovation model algorithms coupled with standard algorithms, so all incorporated on the same sheet. So if we take a look at the pump algorithm, for example, we see the properties are displayed on the left, the tuning parameters and algorithm parameters. Now in the case of simulation algorithms, all of the algorithm parameters are physical quantities that are accessible to a plant engineer. So it would be things like surface areas, tube diameters, things that would come directly off of a manufacturer's data sheet. Now some simulation algorithms have additional properties that need to be edited. In the case of a pump, we have the pump curve itself and the power curve. That can be entered either in a tabular fashion from data, or it can be done graphically where we actually physically draw the pump curve. And all of this data comes right off the manufacturer's data sheet. In terms of the algorithm library in general for simulation algorithms, we have a library today of 70 plus algorithms, and that library is continually growing and being enhanced, where we can, and that's one of the benefits of having the simulation be part of Ovation, because we have complete control over that environment, and we are continually adding enhancements and adding new model algorithms to model specific scenarios. In some cases may be unique to a particular plant, so we can tailor a simulation solution to a particular plant and model phenomenon that may only occur at that particular plant. As I mentioned previously, the Ovation Embedded Simulation product enables multiple use cases for a simulator, each with different requirements of fidelity, accuracy, and detail. For example, the operator training simulator typically includes a complete first principle high fidelity simulation that mimics the plant behavior to a very high level of accuracy. Likewise, the plant engineering department can utilize embedded simulation for engineering functions, like the development and evaluation of new control strategies. These models are typically not required to be high fidelity, and thus can be a mixed fidelity approach to capture the dominant time response and satisfy the logic interlocks necessary for a thorough control application and alarm management design. The power of Ovation simulation enables the plant engineer to develop a simulator to any level of accuracy. The heart of the Ovation Embedded Simulator is the Ovation Virtual Controller technology. The virtual controller provides a Windows-based version of the Ovation controller. The identical software that executes in an actual Ovation controller executes in a virtual controller on a Microsoft Windows-based workstation. This is the identical software. All of the features and functions are identical to the real controller. These virtual controllers typically are a one-to-one replica of the actual controllers in the plant. For example, if a particular Ovation system utilizes 5 controllers, the corresponding simulator utilizes 5 virtual controllers. The virtual controllers enable a feature in a simulation environment that is not possible in the real world. That is the manipulation of time. Virtual controllers can execute both faster and slower than real time. For example, if a turbine startup takes 6 hours in the actual plant, a high-fidelity simulation will also take 6 hours. In some cases, we may want to speed up activities, such as a turbine soak. The virtual controller environment allows up to 8 times faster than real-time execution of the same function. So the 6-hour turbine soak, which is 360 minutes, can be executed in 45 minutes, at 8 times faster than real time. A typical embedded simulator is deployed on a virtual Ovation system. This utilizes virtualization technologies built on commercial products such as VMware that allow multiple Ovation drops to exist on a single server workstation. This allows the performance of the embedded simulator to scale as computing performance increases. The Ovation Embedded Simulation product represents a unique step change in DCS architecture by incorporating simulation functions directly into Ovation. The applications are endless, and the embedded simulator is shaping the future of Ovation architecture as simulation and control technologies become one.